Dynamic allocation in C++. Should we do it on an Arduino? Okay, let's first look at the syntax. The syntax is very simple. We use new and the type of the object, and if it needs initializer, and we put the result in some pointer. And when we end using it, we just delete the pointer with the keyword delete. For array, it's also simple. We also use a pointer to the type that we need. And if you remember, pointers can be used as arrays, and we use new and the type, and we put the brackets. And when we're done using it, we also use delete, but this time with brackets. We can also use it for class objects. For example, the servo. But we can't use it for the encoder. Why is that? The servo has what's known as a default constructor, a constructor that doesn't need any arguments. The encoder, if you remember, when we created the encoder, we put in the constructor 2 pin numbers that we had to put, and there were no default values for them. And so we cannot allocate array of encoders. We could, of course, as the first example was, we could create a single encoder, but not an array of encoders. Some say we should not use dynamic allocation on the AVR-based Arduino at all. Why is that? The Arduino has very small RAM memory. RAM memory is where the variables are stored, and the heap is stored. The heap is the part of the memory that you can allocate dynamic objects on. So let's look at an example. We start allocating objects one by one, and then we delete one of the objects. Now we want to allocate a larger object, which we have enough free space for, but it's not continuous. It doesn't fit in any continuous free block. So it would fail, and the heap manager cannot rearrange the objects because the pointers in C++, they actually hold the addresses in the memory, so rearranging them would break the pointer. So should we not use dynamic allocation at all? Put yourself in the shoes of the creator of a class for addressable LED strips. LED strips come in with different number of LEDs, and the LED strip class instance must remember all of the colors of each LED, because when it refreshes, it needs to send the whole batch of colors of the LED strip. But the number of LEDs in a given strip will not change during the lifetime of an instance, since the LED strip is a piece of hardware. The object will normally remain there for the whole lifetime. So the whole lifetime of the program, until the Arduino is turned off. So if the allocation of LED color representation is done in the constructor or in some other initializing method, the object lives throughout the program, there is no heap fragmentation problem, as we saw earlier, where there is not enough continuous memory, even though there is enough memory. So the same holds for other classes, even if they don't represent hardware, as long as their lifetime is the whole program. You should document that your class does dynamic allocation and when, so the user can use it wisely. Thank you.